Well, good afternoon. As often with the first session in the split rooms, um, it's uh, we have some details to fix. I hope I can. I hope everybody can hear me remotely. I mean,
Yes,
can we
we can
start?
hear.
Okay. So this is the session of the Dynamic Coalition for Interplanetary Network, and this is Can I take your? Hello.
Yeah, we can hear you. Go ahead, Roberto. It's Vince, sir.
Okay. I see that now you can hear me. I was apologizing for the delay. This is the first session in the split rooms, and we had some setup problems. This is the Dynamic Coalition for Interplanetary Networks, and we will be talking about the interplanetary networks and having a focus on the internet governance. The first speaker is Vint Cerf, that doesn't need an introduction. That he will talk about the origin of the project, why the interplanetary networks are important, and what were the whereabouts that brought to the start of this project. Vint, you have the floor.
Thank you so much, Roberto, and good afternoon, everyone. I'm speaking to you from Washington, D.C. in my basement office. It's a pleasure to join you. I just wish I could be there in person. Let me just give you a brief history of this project. Interplanetary communication really starts way back in 1964 when the Deep Space Network was built by NASA with the intent that these large 70-meter antennas be used to communicate with spacecraft that could go anywhere in the solar system and perhaps even beyond. As some of you know, there are two spacecraft that are well outside of the solar system now, Voyager 1 and Voyager 2. The space program continued, landings on the moon happened, and so on. By 1997, a Pathfinder project successfully landed a small rover on Mars, the so-called Sojourner. There had been another successful landing in 1976 of two Viking spacecraft, and then for 20 years, nothing worked. Uh, it was very exciting to see the Sojourner land successfully on Mars, and I was so excited about it. I flew out to the Jet Propulsion Laboratory in California to meet with the team that was handling communications for the 1997 Sojourner mission. And at this point, several of us began speculating about what we should be doing that we are going to need 25 years later. And we concluded that we should start on the design and implementation of a solar system internet. And so that project has been going on for 26 years now. In the 2010s, the project expanded outside of NASA and included the Japanese Space Agency, JAXA, the Korean Space Agency, KARI, and the European Space Agency, ESA. And since that time, during the 10s and 2020s, the four space agencies have been collaborating together with the Consultative Committee on Space Data Systems. Their primary focus of attention has been on the design of a new suite of protocols called the bundle protocols to overcome some of the challenges of deep space operation. We'll hear considerably more about that from my colleagues. The reason that I wanted to take this moment for a preamble is also to say that the reason that we're at the Internet Governance Forum is because governance has become a very critical part of the project. As we look towards commercialization, and many of you are well aware that there are commercial companies, SpaceX, for example, and Intuitive Machines, just to name two, that are actively pursuing activities in space. And in particular, NASA has offered to purchase equipment, rovers, habitats, and the like, and even to buy the product of mining on the moon. And it's the consequence of commercialization which leads us to the importance of governance. And so the point of this session, in part, is to bring you up to speed on where we are technically, and also the demands that we now foresee for governance as a consequence of commercialization. So that concludes my little preamble. Let's move on to the next speaker.
I can't hear.
I think you need to point it that. It's channel 3.
Yeah, but okay. Thank you, Vint, for your introduction. And now I'll give the floor to Kaneko Yosuke, who is the chair of the IPN SIG, and who will talk about what are the activities of the IPN SIG and how the work proceeds. Kaneko, you have the floor.
Okay, good afternoon, everyone. And I'm sitting in Washington, D.C. as well. And I hope I had joined you in Riyadh, but unfortunately, I'll be connecting remotely today. But it's a pleasure to be here. And good afternoon, everyone, to whomever made it to this session. So as Vint just set the floor, I want to briefly kind of address the concept of the interplanetary internet a bit more in detail. For some of you, this might sound like science fiction, but this concept, the interplanetary internet, has been around for quite some time, as just Vince mentioned. And many of the space agencies around the world have been putting a tremendous effort into turning this concept into reality. And today we stand on the cusp of an exciting reentry into space exploration again. We're heading back to the moon more than 25 years after the first inception of the interplanetary internet concept, and over 50 years since the US Apollo mission first landed humans on the moon. And that was back in 1969. And this time, for our next visit to the moon, we are going with international partnership and along with the industry. And this is absolutely the way the interplanetary internet will also be built. And it will advance with the private sector's involvement from its early stages of development. And we really want to realize a common and open and shared network infrastructure, even in interplanetary space. So next slide, please. So one of the examples toward this endeavor will be the LunaNet, which is an acronym of Lunar Internet, which is a collaborative architecture and a framework to provide communication and also positioning and navigation services for activities on the lunar surface. So the LunaNet will essentially become the foundational infrastructure for us to communicate with the astronauts on the moon and the infrastructure that we deploy on the lunar surface. And what's fascinating is that the development is actually moving forward along with the industry, specifically with the recently selected Intuitive Machines toward this endeavor. And next slide, please. So in order to build this interplanetary internet in space, we kind of asked ourselves, what are the key governance principles that we need to pay attention to, and what are the lessons we can learn from history of the internet and the evolution of internet governance. The general approach we sought about was to inherit the good lessons and the good DNA that has matured over the long history of the internet to the model of the interplanetary internet. And so next slide, please. So our dynamic coalition came up with several key principles that might inform the future of the interplanetary internet. And I would imagine that you would see some very familiar language in here, such as having a common way of doing things. We know we need technical approaches like communication protocols and standards to realize interplanetary networking, similar to how TCP/IP became the global standard for every transmission on this planet. And open forums, such as the mechanisms we have at the IETF, will become a real critical enabler to refine the networking technology as we move along. And the hierarchical management, a way in which we manage identifiers like IP addresses and domain names in the internet, will also become an important aspect in space networking architectures. And of course, the multi-stakeholder policy-making process, which is probably the most important part that I want to emphasize today, is a unique governance model, which is at the heart of internet governance. And to me, this was what really made the internet so successful and sustainable as we know it today. So we consider this as a critical DNA that we want to inherit from the internet toward the longevity and the sustainability of this network infrastructure in space. Next slide, please. So regarding talking little bit about the technical aspects, when we're talking about interplanetary communications, there's basically two major problems that needs to be solved. Problem number one is that the speed of light is too slow. It takes 20 minutes to send a signal to Mars and another 20 minutes to get a reply back. So you need to compensate somehow with these high delays. And then the second problem is planetary motion. The Earth and the Moon and the planets always move around. So sometimes we call this orbital mechanics. And that means that a spacecraft can easily hide behind a planet and your communication can be easily disrupted. So TCP/IP doesn't, work very well in these scenarios. So these issues needs to be addressed technically. And there's a technology called the DTN, and the bundled protocol that Vint just mentioned is one of the protocol suites that actually implements this networking technology. And I think you will hear more from my next speaker, Samo, on the developments on DTN. And I think I have one more chart, and that should be the last. Yes. And I just want to draw your attention to the governance report that we have published last year, which really gives more details in our thinking process and recommendations on how to approach governance in the interplanetary internet. And you can also find a postcard of our dynamic coalition if you go to our booth at the venue. So don't miss that out as well. And I think I'll stop here and turn it over to Roberto.
Thank you, Kaneko, for making my task easier, because now Samo doesn't need to have any introduction. He will bring us back to Earth and explain why why people should care about this, and this is not so abstract and far away how it looks. Samo, you have the floor.
Thank you, Roberto. And welcome, everyone. Just a second. I'll try to. Okay, so yeah, my name is Sam Grasic, and I'm currently the lead of the pilot project working group that it's part of the Interplanetary Special Network group. And I tailored a bit my slides actually because after my experience that I got from the booth, because quite often people are asking, this is very futuristic. It's kind of we're looking really far in the future. Why does this concern me? So I will try to maybe very briefly address this question by maybe just explaining DTM bundle protocol is and what can it do. So I think one of the very important aspects that sometimes I think it's a bit overlooked when we talk about DTN as a building block for the interplanetary internet is actually the aspect that this is an overlay network protocol, which means that in this case, I would like to illustrate, like, for instance, we can actually run DTM bundle protocol over today's internet. We can just use regular links as we do it right now. We can actually, we can use it for the high speed, high bandwidth links, optical links. So it's actually quite universal. Of course, we can use it as well for the deep space where we have quite limited resources, limited bandwidth, really high delays, a lot of disruptions. It can handle deep space because it was initially designed for. And then I would like to move to a bit more unconventional, maybe links and ways of communication that is used today. For instance, there's a photo there down with a snowmobile and an antenna attached to the snowmobile. So this is actually from the project that I work, where we actually use the LoRa, not LoRaWAN, but LoRa radio links for a really kind of long distances, to cover really long distances in northern Sweden, where we basically drag the entire network in a very nomadic fashion, so people can move this network. So this population of Sami reindeerherders is actually adopted the DTN technology, and they can actually benefit from it already today. So they can actually track the reindeer and exchange messages with each other, even in areas where they don't have conventional internet technology. I would like to then go a bit further back in time. The other project we work with, actually with the same population, we actually used the helicopter as a data mule. So we had a kind of small devices, put them on a helicopter, and these helicopters were actually flying in and out to these really remote villages that are still today not covered with the conventional internet. And people were able to send messages. Very delayed, it was actually literally maybe 6 to 7 hours of delay for every message we sent, but it's better than nothing. And then I would kind of like to finish maybe with two, maybe a bit more obscure kind of a transfer of data. For instance, having the USB stick, and carry it around, or having the large storage devices. It's actually amazing how much data throughput we can actually do if you put a hard drive, put it on a plane, and fly it to another part of the world. So it's actually really high bandwidth option, and DTM bundle protocol can actually handle that. And the last one is just for illustrative purposes. I think we can use DTN over the smoke signal. So we can go back in time, we can actually apply it I actually am thinking about developing a smoke modulator that would actually allow us to illustrate that DTM bundle protocol could handle that. And then why is this important? Why is this overlay characteristic so important? So this, on the top of this slide, you can actually see some of the potential users of this technology. And of course, space industry is one of the first one that comes to mind. As was already mentioned before, mining, it's surely something that's going to be probably actual really soon. And I think this is, a point in time where actually there's a lot of commercialization happening in space, and surely this will be very actual. I mentioned previously this remote areas and all the people that can actually benefit from this. Logistics is one of these, and lastly, for instance, in this case, we have there are kind of a photo of a scientist collecting the data from the probe. So I think, and this is where I think, in my personal opinion, and I mean, magic happens when it comes to DTN, because we can really seamlessly actually connect any of these users together. So that means, for instance, if you're a scientist collecting data from the buoy somewhere using the USB stick and carrying it, if you apply bundle protocol, you can actually use it, and for instance, to collect the data from the deep space probe. So it's like using the same tools, same software that you're using to collect the data from one thing, you can actually use it from that. So. And if you envision, for instance, how the mining industry might move to the space, as we get more and more commercial actors into it, they will probably not be skilled in deep space communication, and applying DTN for their services already today. They can use them, they can harden them, and then in future, when the time will come, they can actually simply apply this technology in space communication. Space applications. So this is kind of a brief to how I want to kind of illustrate the benefits of DTN from a bit other perspective. And my next slide is about the pilot project working group, what we do there, how you can join and things like that. So one of the main objective of the pilot project working group is to actually build operational DTN network using actual machines, actual protocols, and actually spread it globally. And it's actually quite an interesting exercise. It's actually brings in many issues that maybe was not really kind of seen or foreseen at the beginning, but it brings different issues from technical. We need to adopt, we need to change the protocols sometimes, or get new mechanisms to, for instance, to get a neighbor discovery, to mitigate some of the bad kind of practices maybe from the building the internet. So we are currently in a stage where we're building the kind of second generation of our operational network, where we kind of adopted a bit and develop more mechanisms. We do kind of cover entire globe, so we kind of encircle it. Just I see some colleagues here, like there is no note yet added in Saudi, but I think it's going to appear next week, as it was discussed. So. And yeah, all this kind of practice actually came. Forced us to actually develop certain, or actually push some of even the governance issues. For instance, right now we are actually trying to get the IPN. So it's actually every node in the DTN network gets its own identifier, and it's kind of quite analogous to the IP address. But here it's actually called IPN. So it's and for instance, to allocate those, there is a process because before it was kind of flat space. Now we're trying to find how we will actually distribute these IPN numbers, and for that we will need to set up administrative authorities. So there's surely certain governmental issues that needs to be addressed. In the group, actually, if you join the group, you can actually get the free IPN this number. So if you would want to join. We're actually adding some services as well to it. So we're trying different services, adopt the internet services that we know from today from the internet, and make them compatible so they can actually run more the DTN. Some of the past project were, this project I mentioned before with the Renninghurst, there was actually part of it. We have some sensor networks that we're developing. So DTN has quite a big potential, at least in my personal opinion, in the sensor networks, and especially low power applications, because you don't need to be online, or you don't need to have the radios on all the time. If you synchronize this, you can greatly reduce the power consumption. The main and the most kind of the biggest thing I think in this group is actually we're having regular meetings maybe once, twice per month. And I would really kindly like to invite you all to partake in these meetings, especially if you're more interested in technologies. This group of people that we're kind of having right now, it's actually they're coming from space industry, from academia, from many different backgrounds. So it's a really nice environment if you actually want to be kind of introduced to the delay Turing networks. So with this, I will hand back the microphone to Alberto. Thank you.
And that is a physical handing over. The last speaker of this session is Professor Mohammed Slim Alwini from KAUST, the King Abdullah University for Science and Technology, that is located here in Saudi Arabia, close to Jeddah, and he will talk a little bit about the projects in the university and some terrestrial mostly focusing on terrestrial applications.
Thank you, Roberto. Indeed, I think I'm benefiting here from a very nice introduction made by Vind, by Kaneko, and by Samu. I am, as Roberto mentioned, Professor of Electrical and Computer Engineering at King Abdullah University of Science Technology, KAUST. And I hold the UNESCO chair focusing on connecting the unconnected. So now you may ask yourself, how does this relate to this session and to interplanetary communication? The fact is, as Samu explained, when we talk about interplanetary communication, just because of the very basic law of physics, you have to deal with delay. The example he gave is an excellent example. Even if you go for light communication, which is the fastest possible way to communicate, you need 20 minutes to reach Mars, another 20 minutes to get back the signal. So you have to have a 40-minute delay. And the current terrestrial developed networking protocols essentially has to be modified, adapted, upgraded to be able to deal with this delay. Now, how can we take advantage of this technologies that have been developed for this interplanetary science for terrestrial application? It can be useful actually for very basic problems that we deal with in the Earth, to connect some of the unconnected villages. So, assuming you have a remote village, a hard-to-reach area, where basically real-time connectivity is not possible because we don't have enough funding to have a satellite link, we don't have a microwave link. Now, can we still have a light version of internet, a non-real-time version of the internet? And the solution is yes. So one of my PhD students sitting here, Salah, has worked, for example, on how to develop non-real-time they are called the digital education library. So you can think of schools in these villages who have, let's say, maybe some of you know about Khan Academy. So Khan Academy, you can download it, you can install it in the village, but of course Khan Academy is updated on a daily basis. The village may not be updating this database on a daily basis, but can take advantage of, like Samo mentioned, some form of transportation system. It can be buses, it can be helicopters. If you're on an island, it can be the ships that visit the island every now and then. And updates of the local network can be done through these mules visiting the island. And here we are using delay tolerant networking protocols and paradigm to basically make sure that you are getting your local internet, in this case focusing on education as an example, to basically give access to people in non-real time. And you see here the synergy, or how DTN paradigm that has been originally deployed for or developed for interplanetary science can be used for very basic needs to connect unconnected in hard to reach areas. A second example, and when we talk about connect the unconnected, we are not talking only about connecting people. We are also talking about connecting all kind of IoT device. Now, in many cases, you don't have the infrastructure again to collect information in real time. It is costly, it's complex. So let's assume you are trying to monitor a particular environment for prediction of let's say natural disasters. So you want to throw some IoT device in these hard to reach areas, and you need to capitalize on some kind of maybe network from the sky, a CubeSat that basically come every on a periodic fashion. So basically you have a very small fraction of time where you have visibility or you have access to this IoT device, and essentially you will be able to pick that information and update that information. Not real-time information will be obtained, but in many applications that's not absolutely needed to be able to collect data and predict events. Now, the third and last example I would like to share with you, and that's actually a very nice complement to this session, which is focusing on interplanetary science, is the underwater world. So you probably know that Earth is covered 70%, or at least 70%, I think 73% of Earth is covered by water. And believe it or not, and the first time I heard about this I was quite surprised, I was told less than 10% of the underwater world has been discovered. So there is a lot of engineering that has to be done to learn about this underwater world. And of course, communication, that underwater communication is a big part of discovering the underwater world. And here we have again physics that comes into play. Why physics? Because actually to communicate underwater is quite challenging. There are two approaches. There is the optical approach, which is very limited. We are talking about few hundred meters, high speed, relatively speaking, but only few hundred meters that basically range you can get with an optical link. Or you can use acoustic. Acoustic communication can give you a bigger range, but we are talking only about few hundred to couple of thousand meters of range. That's all, So when you are trying to discover this huge ocean, essentially you will have to rely also, in many cases, especially if it is for exploration and environment monitoring, to embed in the environment some basically sensors, some actuators, and to visit these sensors through AUVs, through ROVs, through basically underwater submarines, and collect and receive information using delay tolerant network paradigm. So that's another example where DTN again can be applied. And just to finalize my kind of intervention here, what are the other related technologies? Often when we talk about delay tolerant networking and connecting these kind of remote IoT device, energy efficiency is a critical aspect. So sometimes you can have access to solar panel if you are above water, for example, for terrestrial application, and that can be your source of energy. But nonetheless, you may want to be even more energy efficient. So one technology that is very popular in this context is wake-up receiver. So wake-up receiver is essentially when you throw IoT device or sensor in the middle of nowhere and you want to be in a sleep mode. Essentially, most of the time, they will be just collect information on a schedule, and then when the event of communication happen, you have to wake them up, and basically through an acoustic mode if it's underwater, an optical that is if it's underwater, or RF it's above water, or optical also above water, and then basically wake them up. Sometimes charge them. You can like use a laser source or an RF source to charge that device and collect the information that has been basically gathered over weeks or even months if you are visiting that location in a very rare fashion. So DTN is an excellent paradigm, and we are borrowing that from the basically interplanetary world, but also wireless power transfer and wake-up receiver is another very important technologies in this context. Thank you.
Thank you, Professor Slim. Before giving the floor for questions, there are two considerations that I would like to make. The first one is it seems that when we are thinking about the internet world, all what we are doing is to get bigger throughput, faster speed, everything in an instant mode where you are continuously connected, continuously online, and we are probably losing sight of the benefit of using technologies that don't give instant response and don't give those big throughputs, but that can better serve specific situations or remote populations that live in underserved areas, or solve specific problems that cannot be solved via a bidirectional immediate connection. And I think that this field has not been explored enough, and I would welcome further research in this area, and not in what is not just in the mainstream internet. And this is, by the way, what universities like KAUST is doing, what groups are working on, and so that's the first consideration. The second one is you might wonder, since we are here in the IGF, and the IGF is basically about internet governance, how all this relates to internet governance. The question is, if I can make a quick parallel between the development of what is now the traditional internet and these new technologies, is that in the beginning the internet was also developed by scientists and was regarding only some niche situation, and then all of a sudden there were the importance, the commercial importance of the internet came up, and all of a sudden we sort of woke up and we realized that we needed a governance model for bringing together different interests and develop a framework where every stakeholder has the possibility to present their positions and their needs. And I fear that the same is going to happen with satellite communication. Interplanetary network, there's a lot of satellites already, and there's a lot of already of commercial interests. And I wonder if in discussing a future asset also in terms of governance of this environment, there are some stakeholder groups that are maybe missing because they will be late in realizing that they have still an interest in how things go. I'm thinking about internet users that will be the last to realize that they have to do something in order to get into the governance of satellite communication or for other aspects. So this is why we are bringing these themes to the attention of the internet governance bodies, and that's why we are here at the IGF to try to start thinking about these things before it's too late and before having to catch up in a hurry and under stress. I see a hand up from Windsurf, and Vint, you have the floor.
Thank you very much for that last point, Roberto, about why are we at the IGF. I wanted to reinforce your observation. Also, I wanted to mention that Slim mentioned the use of DTN underwater. We have done some tests probably more than a decade ago using acoustic communications underwater and the DTN protocols, just for your information. The reason that we're at IGF is because we expect the interplanetary network to be built by multiple parties in the same way that the terrestrial internet is built by multiple parties. And we have to manage and govern that collaborative effort. It will be similarly needed in the deep space efforts. The other thing, which I think is very important, is that the commercialization of space exploration and space habitation and space use creates an interesting challenge. Those of you who are aware will know that there is an outer space treaty in 1967 which said no one is allowed to own anything off of the Earth. You can't, there's no place to register a mine on the moon, for example. You can own the equipment that you place on the moon, but you're not allowed to own the property. My guess is that that will become somewhat difficult. And at some point, we're going to have to be speaking to this question of ownership and commercialization. The question then will be, where do you register any ownership? How do you resolve disputes? What's the jurisdiction in which those disputes get resolved? We don't have good answers to that, but we think the IGF is a good place to raise the questions because that's where multi-stakeholder deliberations take place. And the internet gives us at least some guidance and experience in solving those problems. So we expect to be a regular feature of the IGF as the rest of the years unfold. Thank you very much.
Thank you, Vint, for this contribution, and I surely think that we may, for instance, try to get at least UNO, OSA involved in the discussion for this question that are also legal on the outer space. Now, may I ask if there are questions from the floor?
Kaneko has his hand up, by the way.
Sorry, I don't have a return of the screen. Sorry, Kaneko. So you are the first in line, and then I have other contributions from the floor.
Yes, I just wanted to kind of supplement on what Vint just said. And we do have the Outer Space Treaty. It was inaugurated in 1967. What it basically addresses is that all space activities are nation states activity. even though it is a private sector's activity. So that is the current space regime that we live today. But as I mentioned, the lunar surface would become a hodgepodge of multiple stakeholders' activity. So in the end, we're just talking about interplanetary internet for now, but I would just urge everyone to think about that the actual lunar surface venue will become a multi-stakeholder activity venue in itself. So the interplanetary internet is just one of the aspects that we are looking at right now. So just want to make a brief comment on that.
Thank you, Kaneko. I see we have two questions from the floor.
Thank you. Good afternoon. My name is Felipe Santos. I'm here with the Brazilian Youth Program from the Brazilian Internet Steering Committee, it's GIBE. And I'm also a software developer, and I have been following discussions of internet governance for some time. I had the privilege in attending IGF 2022, where several important topics about digital governance, inclusion, and sustainability were discussed. Building on these discussions, I'd like to bring up some points to connect them with this exciting topic of interplanetary internet governance. In 2002, strong focus was placed on address digital divides on Earth. Ensure that connectivity reaches underserved regions. How can apply those lessons to development of interplanetary internet to ensure that its infrastructures and benefits are equitably shared not just among the spacefaring nations, but for the collective advancement of humanity?
Thank you for the question. I think that probably Vint or Kaneko will answer that. Yeah, go ahead.
It's Vint. Kaneko probably has some answers as well. First of all, the reason that we're doing this network is first very pragmatic. We need it in order to run the various spacecraft to gather data back from them and to send commands, but also to link habitats and laboratories on the moon and Mars and possibly the asteroids in the future. So we need that communication system, but we also are doing it in the same spirit as the original internet design, which was intended to be very collaborative. And remember that the information that's gathered through the Deep Space Network can be made available to everyone on planet Earth by means of its terrestrial internet. So the theory behind all this is to network everything and provide equal access to shareable information for everyone who could use it. So I'm glad that you brought it up. I think our general view is that the information gathered from space exploration should be broadly available, both for scientific reasons and increasingly for commercial reasons. I will say, however, that deep space communication is expensive. It's not nearly as richly outfitted as the terrestrial internet. And so it may be that there have to be constraints on who has access to the deep space component of the interplanetary internet. I think we're not ready for 8.2 billion people sending their cat pictures through to Mars, for example. So there will probably be limitations on who has access directly to the Deep Space Network or the interplanetary network, but its results should be broadly available terrestrially. Kaneko, maybe you have some more elaboration on that.
Yes, Kaneko, if you have something to add, may I ask questions and answers to be sure that I have 4 other people queuing up for questions.
Okay, I'll make it quick then. So basically, I completely agree with the comment. There's going to be these discussions on digital governance in the interplanetary internet, and I think we should really learn from these histories from back in 2002. And commonality of the infrastructure and equitable access. I think these are really key principles that we need to pursue for the interplanetary internet. And as far as how we can bring the non-spacing spacefaring nations into this endeavor is that we have various forums in space. Like the COPIUS is one of them, like the United Nations Committee on Peaceful Uses of Outer Space, where the nation states show up and talk about policies and rulemaking and information sharing. So these could be one of the venues that the non-spacing faring countries can join, and actually information can be exchanged and can have access to these common infrastructure. So I think these are steps that we can take for now, as of now, and I think we should advance that in the future.
Thank you, Kaneko. Auke, you have the floor.
Thank you very much. Yes, my name is Auke Akpals, working for KPMG in the Netherlands. I do really understand the need for governance of the interplanetary internet. While we've seen that in the past, and for sure we must have a debate about that. However, what I've more difficulty with understanding is how can we make the delay from 40 minutes to a fraction? Is that a possibility, or is that not even possible? And do we have to deal with that? Because I'm a quite impatient person, and I don't want to wait 40 minutes for my cat picture to to be sent into space. No, thanks.
It's Vint. You can see Kaneko and I are both laughing. Unfortunately, Dr. Einstein has pretty much prevented us from solving the problem you pose. The speed of light is finite, and as far as we know, we don't know how to make photons run faster than the speed of light. The consequence of this is that the delay is inescapable. And before you decide that entangled photons will solve the problem, let me tell you that that doesn't work either, despite the fact that entanglement may be distance independent. There are still, you can't use that for communication. You can only get correlation out of it. So I'm terribly sorry to tell you that we can't solve your problem with today's physics.
So can we go to the next question? If you can come here, then you can use one of our microphones.
Hello. Me? Thank you so much. Excellent presentation. I'm Kambar Seymour from the United Kingdom Foreign Ministry. This is quite new to me, so I'm just soaking it all up. But I'm just wondering, to what extent are you factoring into account the human rights elements of the sort of future interplanetary internet? Is that something which you think is relevant at this stage? If so, what are the key considerations which you need the multi-staker community to help you on? Thank you.
Maybe I can say a word on this. Yes, this is the main reason why we would like to bring this to the attention of the Internet Governance Forum and to the other Internet governance organizations, so that we can have a debate on this and make sure that the human rights are taken care in the development of a policy. Thank you for the question. Is there any Vint, do you want to take this question as well?
Yes, I would. Thank you. Just very briefly, keep in mind that the architecture of the interplanetary network is intentionally open. It's designed to allow multiple parties to participate, to implement and share resources. However, I want to emphasize that the resources of the Deep Space Network, or the interplanetary network, will probably be quite limited, at least in the early days. So we have to be very careful not to accidentally assume that human rights means everyone on the planet has access to and the direct use of these assets. Instead, I think we have to make sure that they have access to the product that is carried to Earth through the Deep Space Network, but not necessarily everyone will have direct access to it. because of its limited capacity.
Very short comment from my side as well. It's like I think what's good maybe with the internet, I mean, or interplanetary architecture is that by the definition it's kind of a distributed. It's going to be probably very hard to centralize in a way that we centralize internet today. So that's just, I think, one interesting aspect to look into. So.
Thank you. Two more questions. Let's be short. I already had the 5 minutes flag raised.
Okay, hello everyone. My name is Alan Veloso. I actually work for the Brazilian Space Agency. I'm an international cooperation advisor there, and I'm also part of the youth program from Brazil, from the Brazilian Steering Internet Committee. My question would be, actually it has already been addressed about how do we get other nations to this project, because if you count, there are only a handful of nations that owns the capacity to develop these projects and to participate. So I would like to, if possible, to elaborate more on that, but bringing the international cooperation as a principle to this project, to the 5 principles that you mentioned before. And also I have a question that maybe it's more technical, related to the sustainability, because we know that I think that radio frequencies are a limited resource. So I don't know if there are some key considerations that we must acknowledge on this project while addressing the interplanetary internet. Thank you.
Who takes this short question?
It's Vint. Just very quickly. The network is intentionally designed so that multiple parties can implement and operate it. I would also point out to you that the Consultative Committee on Space Data Systems, unless I've missed my guess, is open to participation even by countries that don't necessarily already have lift capacity. The other reason that this is getting better is that lift capacity is now commercially available through SpaceX and others. And the consequence of that is that countries that normally would not have space capability now have the potential for participating, either by directly accessing lift capacity from companies like SpaceX and others, or by collaborating with others in order to share that capacity. So between that and the notion of a shareable deep space network, it feels to me like countries that don't currently have space capability have an opportunity to participate.
Regarding your second question about sustainability and scarcity of spectrum, indeed the RF spectrum is more and more scarce, but typically for interplanetary communication, to my best knowledge, what we can go for is free space optics. So basically we'll be using the optical band of the spectrum, which there is plenty of still at least of available wavelength and spectrum to be used. So I don't think we have a problem from that perspective for interplanetary communication.
Thank you, Slim. Next question.
Kaneko has hand up.
Yeah, briefly. Yeah.
Just briefly, I just want to add that on the capacity building part, please come to ipnsig.org. We have a full repository of how DTN works and what the interplanetary network is, and it's all free for use. So I think that this is a good source for people to join this endeavor. And regarding the lunar frequency that you've just mentioned, there was a resolution at the WRC last year to assess the lunar frequencies, and I think this is going to be a top of the agenda for the upcoming WRC in 27. So just a quick note on that.
Thank you, Kaneko. So next question.
Hello. Okay. Thank you very much. All right. Thank you very much for that wonderful presentation. My name is Kunle Olorundare from Nigeria. I'm a member of a special interest group in the Internet Society, space, so to say. At the same time, I'm the president of Internet Society in Nigeria, and I've been following this discussion, this conversation, even before now. And I'm happy that we are discussing this even at the level of Internet Governance Forum, because I think it's one of those things that we need to really take a deep look at. And also, I'm happy that the last speaker mentioned the issue of lunar, frequency, because it's one of those issues that we're looking at WRC. By the way, I'm a member of the 7C agenda, so to say. So my question is this, because I'm so much excited about this discussion, and I think probably maybe there may be a way in which some of us will be able to contribute to, the pilot project working group. So I want to find out, if I want to join the pilot project working group, is it something that one can come on board for?
Yeah.
Thank you very much.
Yep, we are.
The chairman of the group, I'm sorry, it's Vin. The chairman of the group is Samo, and so you need to talk to him.
Okay, maybe if you can take the answer offline, because we are out of question. I will. There are also some cards explanatory of what is our activity, that they are in the booth of the dynamic coalitions. We don't have time for wrap up, so we just.
Very quickly, so if you go into the ipnsig.org page, and check the project working group, you can just join in. You can actually partake. It's open, it's free. So we welcome everyone, especially, people interested in the space that would like to get their hands dirty with this technology. So welcome.
Thank you all for coming. We had an almost full room, so thank you for coming, and enjoy the rest of the conference.
Thank you all.
Thank you, everyone.
Well done, Kaneko and Samo and Roberto and Slim. Thank you so much. See you on the net.
See you.